Today I am going to start the third chapter of class 10 maths, and as you know, that is pair of linear equation in two variables. Pair of linear equation in two variables, and the most common form of linear equation is ax plus by plus c is equal to 0. This is the most common form of linear equation. And here a, b, c are real numbers, where a, b and c are real numbers. And as you know, x and y are variables here, and c is the constant term here. So this is the basic form of linear equation in two variables. But here it is pair of linear equations. Pair of linear equation means two linear equations should be here. The basic form, most common form of pair of linear equation in two variables are, please see here, a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Really, this is the most common form of pair of linear equations. Pair means two in number. First one, second one. They are forming a pair undoubtedly. And where a1, b1, c1, a2, b2, c2 are real numbers. But one thing you must keep in mind, a1, b1, a2, b2, these all should not be equal to 0. Otherwise, they will lose their existence. Existence of happening here, pair of linear equation in two variables. So, they must be non-zero numbers. And look here. And the pair of linear equations, in brief, in short, it is known as linear pair also. It is known as linear pair also. You will keep in mind. Pair of linear equation in two variables, in briefly, is known as a linear pair. A linear pair. You will keep in mind. A linear pair can be represented, can be solved in two ways. Can be represented or solved in two ways. First one, graphical method. And second one, algebraic method. Students, we have arrange one table here in which three pair of linear equations are here, and in this column, in this table, different columns are there, and really A1, A2, a little, a few minutes back, I made, a pair of linear equations in this form. Look here. A1x plus B1y plus C1 is equal to 0. A2x plus B2y plus C2 is equal to 0. This one, look here. This is, as I told earlier, okay, this is the most common form of a pair of linear equations. A1x, B1y, C1 is equal to 0. A2x plus B2y plus C2 is equal to 0. So here, really these are the ratios. Means A1 by A2, A1 by A2, B1 by B2, look here, B1 by B2 and C1 by C2. So these are the ratios of real numbers given in that pair. And I have written the ratio here. Look here. Here are different columns. First one, as I told, pair of linear equations, three pair I have taken here. Second one, ratios of real numbers, A1 by A2, B1 by B2, C1 by C2, and compare the ratio. In this column, we will compare the ratio. And here in this column, in brief, there is a graphical representation. Graphical representation. And last column here, algebraic representation. Algebraic representation. Graphical representation means, as I told, and I am telling right now here, a straight line is there. A straight line is really the graph for a linear equation into variables. And so here it is in pair. That means two lines will be there on graph paper, and their conditions are given in all three. For all these three pairs of equation, conditions are given now. Ahead I will explain it now. And this is algebraic expression here, algebraic representation. That means I think we go, for the values of x and y, and if possible, if the value is possible there, so different conditions are given here now. So let us start here. The first one. Here A1 is what here? Means coefficient of x is A1. A1 means coefficient of x. Nothing is here, that means 1 will be here. So 1 by here A2. A1 by A2. A1 is coefficient of x and A2 means coefficient of x in second equation now. So 3 is here, so 1 by 3 will be here. And here B1 by B2. So similarly, what will be here? Minus 2 by 4 will be here. And third one is C1 by C2 here. So that means I think nothing is C here. C1, so here will be what? 0 by minus 20. C1 by C2. That means I think you will cancel this one here. So minus 1 by 2 will be here. Minus 1 by 2. Look here, minus 1 by 2. So here A1 by A2 is equal to 1 by 3. B1 by B2 is equal to minus 1 by 2. So it is clear that A1 by A2 is not equal to B1 by B2. A1 by A2 is not equal to B1 by B2. If this condition is satisfied, if this condition prevails here, that means its graphical representation will be two intersecting lines now. Means they means the two lines will intersect at one point. This will be the graphical representation if this condition prevails. And if you go for algebraic representation, that means they will have exactly one solution. Means the value of x and y will be unique one, means single one will be there that will satisfy the equations now. And if you move to second equation here, and a1 by a2, that means 2 by 4 is equal to 1 by 2 after cancellation, and 3 by 6 after cancellation 1 by 2 will be there, and c1 by c2, that means minus 9 by minus 18, cancellation means 1 by 2. Here also will be 1 by 2. Look here, that means 1 by 2, 1 by 2, 1 by 2 means all three ratios are equal here. They are equal to 1 by 2 means a1 by a2, b1 by b2, c1 by c2. If this condition prevails here, that means both straight lines, means both graphs will coincide each other. Means really they will be the one line now. And their graph, as I told, those lines will be coincident lines. Coincident lines means one will overlap on the other. And it means if you go for algebraic representation, means they will have infinitely many solutions. Means so many values will be there of x and y, they will satisfy the given pair of equations. Infinitely many solutions. Means all points, all coordinates on the graph, on the straight line will be the values of x and y, will be their solution, I mean to say. And if you move to third pair of equation here, that means I think 1 by 2 will be here and 2 by 4 will be here. After cancellation 1 by 2 will be here. Hence minus 4 by minus 12, that means after cancellation 1 by 3 will be here. Here a1 by a2 means the ratio of this one is 1 by 2. Ratio of b1 by b2 means 1 by 2. And c1 by c2, this ratio really is equal to 1 by 3 here. So it is satisfying this condition. Means a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. Look here. a1 by a2 is equal to b1 by b2 but not equal to c1 by c2 because c1 by c2 this ratio is 1 by 3. So in this condition the graphical representation will be parallel lines. Means both graphs, both straight lines will be parallel, they will never cut each other. And in this condition, if you go for algebraic representation, that means there will be no such values of x and y. There will be no such values of x and y which will satisfy both the equations. So these two columns really are showing here graphical representation and algebraic representation. If this condition prevails, intersecting lines will be their graphs now and exactly one solution. If this condition prevails here, that means there will be coincident lines and many solutions will be there, many values will be there of x and y satisfying the given equation. And if this condition prevails here, that means graphical representation means will be there the parallel lines, means they will not cut each other, and so that is why there will be no solution. So this is the condition here. And if you move to, and in brief I am going to show you, I have made a rough figure. So now this is the rough figure for graphical representation. As I taught earlier, look here. This is the graph for the pair of linear equation, and I think one condition will be here. Both lines will intersect each other at one point, and I think they will intersect at one point. That means here will be one coordinates now here. Means suppose it is 5 and 6 here. So that means this is the value of x, this is x coordinate and this is y coordinate. Value of x roughly and y, the value of y it is. And in this condition, as I told earlier, they have a unique value now. Means only one for both x and y. Second condition, as I told, their graphs means both line might be coinciding now. They will coincide each other as this graph is showing now. Both lines are coinciding each other, and so many points. Suppose it is 3 and 4, 5 and 6, 7 and 8. Look here. So there will be so many values of x and y which will satisfy the pair of given equations now. So in this condition, there are infinitely many solutions. And look the third one now. Third graph, both lines really are parallel. They are not intersecting. They are not coinciding. In this case, there is no value. There is no solution. There is no such values of x and y which will satisfy the pair of equations. So this is the graphical representation. And I think if anything is left here, then I will try my best to present in the next class, but I will try to touch the exercise given in your book now here. Now look the very first exercise of chapter 3. Aftab tells his daughters, 7 years ago, I was 7 times as old as you were then, and also 3 years from now, I shall be. This is the question here now. So first of all, you will have to suppose the present ages of both. You will suppose here, exercise 3.1, first number. Let Aftab's daughter's present age. Aftab's daughter's present age is equal to x years, and Aftab's present age is equal to y years. Means we have supposed here the Aftab's daughter present age and Aftab's present age now. 7 years ago. So 7 years ago, 7 years ago, daughter's age will be what? X minus 7 years. And Aftab's age is equal to y minus 7 will be. Are you getting? X minus 7 will be the daughter's age 7 years ago, and Aftab's age will be y minus 7. And then condition is here, I was 7 times as old as. That means, according to question, that means y minus 7 is equal to 7 into x minus 7. Like that it will be now. Y minus 7 is equal to 7 into x minus 7. And you will try to rearrange this one here. Like, or y minus 7 is equal to 7x minus 49, or 7x minus y is equal to, I think, 42. Yeah, this is the equation. This is the equation and this is the algebraic representation. This is the algebraic representation. And one more condition is there in this question. I think like that, like this, you will find the second condition also here. And second condition, from 3 years from now, I shall be 3 times. 3 years from now means after 3 years. After 3 years, that means y plus 3 is equal to 3 into x plus 3, like that it will be now. This second equation for question number 1. That means y plus 3 is equal to 3x plus 9 and 3x minus y is equal to minus 6. This will be second equation. Look here. This is the first equation and this is the second equation. This is the algebraic representation of question number 1. And I think graphically also is to be shown here. So that means for graph you need one value box there. You will at least you need 2 solutions for graphical representation. In this manner, look here, quick. X, y. At least 2 solution you require for this equation here. And 7x minus y is equal to 42. 7x minus y is equal to 42. That means you will take the value of x here. You will suppose the value of x, any number you can suppose here. Suppose 0 it is now. It is 0. Then if x is equal to 0, then what will be what you see here? I think 0 minus y is equal to 42 and y is equal to minus 42. I think minus 42 will be here. Then you suppose another number here, like suppose 2 now or 3. Then 7 3 is 21. We will subtract here 21, so minus 21 will be there, like that. Look. So after the value box, you will draw the graph here. You will draw the graph here, like that. Like that you will draw the graph. This is the graphical representation. And I think similarly, next 2 question you will do in this manner. So in exercise 3.1, you will not go for the solution, you will not go for the value of x and y, only you will write equations, means algebraically how they can be represented, you will write that one, and graphically how you will make graphs here, how you will do graphs here, only that thing you will draw here, that thing you will do. You will not go for solution in exercise 3.1. Now move to exercise. Now we are moving to next exercise 3.2, because almost these 2 exercises are the same here. The very first question of exercise 3.2 is here. We form the pair of linear equation in the following problems and find the solutions graphically. Here we will go for the solution now, graphically. Means if unique solution, I think there will be one unique value for x and y now. So in question number 1, in exercise 3.2, you will form linear equations algebraically, and then graphically you will draw the graphs, and the meeting point of the graphs will be the values of x and y. And if you move to second number question, as I taught earlier, the comparison of the ratios like A1 by A2 is B1 by B2, C1 by C2. So first of all, you will write the values here and then you will compare. And conditions, I have already told you all. Conditions I have already told you all. And here, you find whether the lines representing the following pairs of linear equations intersect at a point or parallel or coincident. Means for all these equations, you will get the ratios A1 by A2, B1 by B2, C1 by C2, and then you will compare the condition I taught earlier in a box. And if A1 by A2 is not equal to B1 by B2, that means they will intersect at a point. And if all are equal, if all ratios are equal, as I told the conditions there, if all are equal, then they will coincide, means there will be so many values now. And third one, if A1 by A2 is equal to B1 by B2 but not equal to C1 values of x and y. And now third number question is here, consistent and inconsistent. It is very easy, it is child's cake now. In condition of unique solution and infinitely many solutions, there will be consistent. It will be consistent. Keep in mind, if unique solution and infinitely many solutions, then it will be consistent, and if there is no solution, then in that condition it will be inconsistent. So question number 3, I think you can easily bifurcate whether it is consistent or inconsistent. And question number 4, which of the following pairs of linear equations are consistent and inconsistent? If consistent, obtain the solution graphically. If consistent, then you will solve the equations graphically, means you will draw the graphs. If unique solution, no doubt they will intersect each other at one point, and that coordinate will be the, I think, answer now. X coordinate the value of x and y coordinate the value of y. And if they coincide, then there will be such values now. And I think some more questions are there. I think you will try yourself. Any problem prevails. If you face any problem, then in next class I will try to clear it. Thank you.